I'd like to invite on stage Vikas and Yogi from Flipkart to begin their talk on the art of promising. For those
Hello, everybody. My name is Yogi. This is Vikas.
Hi.
We both work in the supply chain team at Flipkart, the team which is kind of responsible for everything from the time we promise to the time the product gets into your hands. Uh, Vikas works in product. He's a product manager now. He's working much more closely with business. And I work in technology. And as you can see from our uncannily similar shirt choices, product and tech is very aligned in Flipkart. So our talk is about the art of promising, and so this is a nice quote which came across, which says that a promise is a cloud. The sight of a cloud is more a promise. It's rain which is really the fulfillment, which is the proof in the pudding. And it seemed very apt to our talk, and thought we'd just put it up there. So I want to talk a little more about this notion of promise and fulfillment. These are two ideas that we've started seeing appear repeatedly in many of the systems and services that we've been building at Flipkart. And we're going to be talking a lot more about the importance of actually identifying these, which are very often very implicit within your systems, and actually making them first class, actually bringing them out and separating them. So we'll be focusing a lot about that and about the patterns and learnings that we've had in our journey from in taking promise from where it was to where it is now. So I want to touch briefly on this notion of policy and mechanism. A lot of you might have heard about these ideas. They appear in systems ranging from operating systems to large-scale service-oriented architectures across domains, whether it's e-commerce, trading, just pretty much think of any application and you'll have this notion of policy and mechanism, which are, I'll kind of flesh them out a little more. So policy is typically about the what. What are you trying to do? And it relates very strongly to this idea of promise. It is far more customer-oriented. It's far more outward-facing. It talks about what can we offer as a system to our consumers. From an e-commerce perspective, you also kind of, or even from point of view of resource allocation, for example, you can kind of bring in the aspect of what is the price to be charged to a consumer for using that service. So policy is something which changes fairly frequently. It allows you want a lot of flexibility there, and actually carving it out separately actually gives you that lever. The second is mechanism, which is more about the how. It relates much more strongly to the notion of fulfillment, and it's far more supply oriented. It's about, okay, I have this policy, how do I make it work? How do I get it done? How do I deal with the costs associated with it? How do I lower costs, right? So it's all about the how, and it's relatively stable. Now, the rules and strategies there might be very rich, but the overall strategy is fairly stable compared to policy. So if you think about a typical system or services evolution, this is a pattern we've kind of started seeing over the last few years at Flipkart, and probably you might identify with it. So a service starts with a notion of mechanism, a notion of fulfillment, right? It's all about just getting something done. And slowly you realize that this notion of promise is actually very much there, and your system starts becoming more difficult to change because of policy changes. And actually bringing it out separately gives you a very, very powerful lever to kind of evolve it at a much faster rate than you can evolve mechanism. So you typically start separating those pieces out. And this might be at the service level, it might be just a library, but just identifying that these are two separate pieces and concerns is a big first step. But what we are going to argue in this talk is that you have to take the next step forward, and that is to actually break up the fulfillment piece further into two parts, one of orchestration and the other of execution. And orchestration here is about how do you get it done no matter what, in the face of failures. Things are not working, you retry it in some other way. Maybe change how you're going about doing it, right? So this notion, again, is something we've discovered or we've kind of found in our systems, that we actually bringing it out separately, again, gives you a very powerful lever to evolve that piece, regardless of what the underlying execution mechanisms are. Those are very, very stable. So before I kind of go to the next slides, Vikas will kind of talk about, so I want to just highlight why is this important. As Amod and Sachin mentioned about this notion of moving far more towards intelligence and systemic decision making, we've realized that actually identifying these three concerns is a very important stepping stone towards actually real-time system-driven decision making. And we kind of talk a little more about that as the talk proceeds. So we'll kind of take a sidestep and talk about how promise at Flipkart has actually evolved, and that'll be the underlying theme which kind of will make these insights a little more real. So Vikas will talk a little more about that.
Thank you, Yogi. So I guess Yogi has set a good context around where we are kind of moving towards, right, from fulfillment to promise and fulfillment. So keep that picture in mind, and maybe that will help you to kind of connect the dots as we kind of proceed further with the presentation. So if you see the promise evolution, say promise, like this is like the Flipkart product page. Promise part that you're talking about is the one which is highlighted there. So that is what, just kind of keep that in mind when we're kind of talking about promise. See like how it has evolved. So if we kind of go back in the time, the left side kind of shows how it used to be earlier. We just used to kind of have like a static place where we say like, whether do we have inventory for this? Oh yeah, we have it in our warehouses. Let's tell people that we'll be able to deliver it in 3 days. Irrespective of where you are, from where we are kind of shipping it, doesn't matter, we'll kind of just say 3 business days, right? So that kind of has changed a lot. Now if you see the promise, it's much more richer. We are talking about customized promises for the customer, and there are multiple options of the promises which we are giving to the customers over there. So we've seen that transition. So we'll just talk about how that transition happened, and on the journey, like what are learnings that we had, which Yogi will then share in the end. Now before we kind of go to the promise part of a thing, let's try to understand the fulfillment so that we can connect the dot of fulfillment to promise and fulfillment then again, right? So we need to understand how the fulfillment works before we can even talk about the promise. So this kind of quickly walk you through how you kind of get products in your hand when you actually order from Flipkart so quickly, right? So if you see the box here below, that is kind of like the Flipkart fulfillment network that is made of kind of multiple pieces, and we see kind of how these kind of pieces kind of talk to each other and kind of how the flow happens for fulfilling the order. So customer comes on website, he likes some product, he places an order, it goes to an order management systems, bunch of stuff happens, goes to fulfillment, who then kind of takes some intelligent decisions around how to fulfill the order, right? Is it coming from a seller fulfillment, or Flipkart is fulfilling those, right? So based upon that, some decision will be taken over there, and the sellers will be processing it, or be kind of packed kind of stuff in the fulfillment centers. Then we pick up from the seller location, and then we kind of hand it over to our logistics, or maybe the 3PL partners that we have. And finally, the logistics will go and deliver it to the customers in their hands. So you can see it's a kind of this is like kind of very crisp. Obviously, there are multiple things which are happening within each of these boxes. I'll not kind of go into detail around that. Otherwise, you'll need like another kind of an entire day around that itself, right? But this kind of shows like how complicated the entire end-to-end supply chain is, right? And how like the promise will be mapping it in the real-time promises when it is making to the customers over there. Let's try to understand more about what is promise all about, right? What we're kind of showing over there in the diagram, what is it all about, right? What does a customer care about when he's looking for a promise, right? You say, is the product available, right? Well, it will be, we mean like, is it in stock? Is it out of stock? Is it like on a pre-order, right? Or supplier has it, or the supplier will be, or the seller will be procuring it and then kind of shipping it to me. So those kind of questions come into mind when customer is looking for a promise over there, right? Then the other thing is, okay, the product is available, but is it serviceable in my location, right? As I said, the fulfillment network is kind of pretty vast over there, right? We are talking about multiple kind of products. There might be some kind of a large products which is not possible to kind of ship from one part of the country to another part of the country, right? So we have like multiple courier partners over there. They might have their own limitations. Some may not be able to provide you a cash on delivery service in some other locations, right? There'll be some sellers which might not be able to ship to some products to your location due to multiple reasons at their end, or multiple litigations that we have around, right? So it is very important to kind of tell customer whether the product is serviceable and what all services we can give it to you. Along with it, very important one is how long would it take, right? What is the SLA, the service level agreements that we can go up with the customer over there, right? So customer would be willing to know, if I'm ordering from Bangalore, how much time would it take for this product from this seller to reach to my location, right? That will be very important. Again, in this, promise has to understand the entire fulfillment network end to end, see how much time will the seller be taking it to pack the item, right? Then after that, the logistics has to pick it up. What if there's the seller is not working for some days, or the logistics partner is not working for some day, or some strike has happened at some particular place, right? So all those kind of things we'll talk about more, but all of those goes in the real time when you're calculating the actual SLA that you have to show to the customer. So you have to map the entire supply chain and kind of show it intelligently to the customer on the scale. Another important thing is like customer would like to know, I have to gift it to somebody, tomorrow it's a birthday, right? Can I get it delivered tomorrow itself? Is it guaranteed, right? So that element will come into the picture. I'm leaving out of the station. I want this book in my hand so that I can read it on the flight, right? So those kind of things will be there. And obviously, intelligently, can the promise be personalized? So promise will be very different for a metro customer versus a tier 3 customer, right? A promise will be very different, let's say if you're ordering on a commercial address versus a residential address. If it is a residential address, maybe we can promise you for a Sunday delivery. If it's a residential, if it's a commercial address, we cannot promise you a Sunday delivery. So those kind of, all of these things together will kind of play a key role in kind of defining the entire promise that we're giving to the customer. And that, all the parts put together make it even more complicated over there.
So the aspect of promise is also kind of extends to the whole browsing experience and the search experience, where you could go to the extent of saying that if there's somebody who's staying in a tier 3 city, and you're constantly telling him that, okay, products are available, but they're not serviceable to you. You know, that's kind of frustrating. So can you customize the experience, the entire browse experience, based on where the person is living and where he wants his deliveries to be, right? That's a very, very challenging problem, and that's something we're looking at tackling.
Okay. So in the previous slide, we have seen the fulfillment picture. Now let's see how we have moved that fulfillment picture and kind of broken it up into promise and fulfillment at Flipkart, right? So those are like the two building blocks of the entire fulfillment that is broken up into, right? So what you're saying is promise engine gets all the information and promise it to the customers, what is available, what is serviceable, right? So that will be getting multiple signals around that. So like there will be fulfillment settings, which will be telling it what is the time that I'll take to pack and dispatch the items, right? It will be saying what is my inventory levels that I have currently, right? What is the capacity that I can do? Can I do 1,000 items an hour? Can I do 2,000 items an hour? Those kind of capacities will be coming into picture.
So FC here is the warehouse. It's, hello? Yeah, is the warehouse. So it's the fulfillment center.
The logistics will be talking about all the SLAs, like from one source to destination, from the seller source to the customer destination over there, right? There'll be capacities around that, what cutoffs is required, at what time does my plane leaves, what time does my train leaves, what does my surface transport leaves over there, right? There will be multiple holidays around in the multiple parts of the country. What is serviceable? Is COD serviceable or not, right? What are the limits around that? So those are the multiple pieces, signals, which logistics will be again giving to the promise piece. Then there'll be some items will be fulfilled by the sellers directly. They'll be having it in their location, they'll be packing it, they'll be shipping it. So around that, again, getting their availability to promise, their SLAs around that. So all of this promise engine is again tying up all the signals, putting up intelligence everywhere, and kind of try to stitch the pieces end to end. So the customer doesn't have to bother about all of those, and they just see a final promise on the website, and then they can place their order accordingly. So once the order is placed, it comes to orchestrator, which kind of duty is to kind of fulfill the order within this promise and also optimize the entire network and make some money for Flipkart over there. Right. So again, in the FC, it will be giving instructions like by what time the reservation is done, by what time it has to be dispatched, so that the next leg can kind of get in time and can be finally delivered to the customer. It will give instructions to logistics around delivery, right? Where the delivery has to be made, by what time it has to be made. Is it like in a day guarantee, right? So in that case, you have to give a clear instruction that use these kind of a transport modes, this kind of a, maybe the prime connections over there, which will help us to kind of meet the guaranteed delivery to the customers over there. And there'll be, again, a communication with the sellers over there for the seller fulfill orders, again, giving them clear, precise instructions around what to do with this order so that it gets fulfilled to the customer. And there'll be a kind of a feedback loop from all of these systems, again, back to the promise, right? So orchestrator keeps on hearing from FC, seller, seller and everybody, and they keep on passing back the feedback loop back to the promise so that both of them are kind of in sync. They're working together and kind of making sure that the auto correction is happening intelligently as the kind of things are progressing in the real time itself. So this kind of now talks about like how the fulfillment has been broken up into promise and fulfillment in the Flipkart context. And now Yogi will talk again about, while doing this, what all challenges we had and what were the learnings that we got out of that.
So, as Vikas mentioned, one of the biggest challenges was actually characterizing promise. From a conceptual point of view, what does promise mean? And we spoke about some of the problems, or what are the kind of customer viewpoints that we want to address when we spoke about availability, serviceability, etc. Right? But then characterizing what is the aspects of the supply chain which influence each of those. I think that itself was a fairly interesting conceptual problem. and mapping all these signals from multiple systems to actually come up with a concise, realistic promise was important. Again, here there's a big trade-off between the richness of the promise that you can make and the speed, latency, etc. that you need to deal with to kind of the amount of data you need to handle to kind of make that promise. So it's constantly a trade-off you've got to make, and at some point you've got to kind of say that, okay, let's not use this signal, but let's use this signal, and kind of learn from that data and then move forward. Keep calibrating your promises as you go forward. One of the biggest challenges for the promise engine is that it's expected to be web scale. It sits directly behind the website, which is getting at peak right now. I think we're doing I think last month, one of the peak days that we had close to 8 to 10,000 requests per second. And this guy has to come in. So Promise Engine is asked a question about availability, serviceability on every page view, on every product page view, right? That's a huge percentage of the requests are actually going all the way down to the Promise Engine. So performance has to be critical. And the expectations we had been set was that the response at the 99th percentile has to be within 30 milliseconds. So that was a key constraint or challenge that we had to deal with. The way we kind of dealt with it and some of the patterns that emerged from there is this notion that you should separate out services which are expected to be web scale from services which are not, right? And this is a very, very powerful pattern. It's very simple. It's almost intuitive. Yeah, you know what? Of course. But very often we fail to do that until systems break the first time, and then you kind of rush to kind of fix that problem and put something in front, right? So as a kind of pattern, thinking about is a service going to be at web scale or not is a very important architectural decision, a design decision that you have to make upfront, and kind of carve out a separate piece to deal with those requirements explicitly. The second is that the kind of signals we are getting are from a lot of underlying systems, and you can't query them again in real time. You have to kind of buffer these downstream systems, which are the actual data providers, from actually needing to be at web scale, because there's an implication of cost, there's an implication of uptime, there's an implication of this reliability, which doesn't need to leak from the web scale tier to underlying systems, which are far more and far larger. So it's important to kind of separate these out. So we can't actually go and say that, okay, every time Promise Engine gets a request, it'll go out and ask the warehouse that, no, tell me what's your inventory levels. That just won't work because the warehouse system would need to then scale to that level. That's not a good idea. So instead, what we did was to actually use this notion of domain events. So domain event is a notification about something that happened somewhere, right? So for example, warehouse can raise a domain event saying that, okay, you know what, inventory just got added in this warehouse, note it. Or somebody can say, I've received an order for this product, or that someone's a shipment has been dispatched, has it been delivered? So all these are basically life cycle events in that entire process of your service or services. And actually raising events gives you a very, very powerful mechanism to do custom logic on the edges, which doesn't need to actually kind of interfere with the core system which is generating. You can actually have far more rich mechanisms on the edges without that core system changing. So we use granular domain events a lot. So our systems raise millions of events through the day, and Promise Engine is basically listening into these events and continuously computing its state of its promise. So one of the important things in this to make sure is that those events are actually reliable. So reliable from a point of view of transactional correctness. So what does that mean? So it means that suppose an event or say a warehouse is processing a transaction to add inventory to its systems, and that event got sent out, but the transaction failed, right? So the actual event in its database was not there, but the event actually went out to the world saying that it's done. So this notion that both the event being sent and the write to the database has to be in one unit is very, very critical. Otherwise, you're going to basically get false messages, false events, which you're going to have to correct for, right? So we actually end up building a messaging system called REST bus, which Amod spoke about, which actually gives those transactional guarantees at scale. So that's critical. It's important to take that into consideration, that notion of transactional unit. The last is this idea of data size management. So Flipkart today has an inventory, has on its catalog over 20 million products, right? I can't maintain a promise of all these items across all warehouses, the amount of memory required or just storage required to store that and be able to, so it has to be in RAM. It can't be on disk because I want to serve it very quickly. So then you've got to make a trade-off again. So here we again used learning and algorithms to kind of basically keep filtering down the set which is most relevant and only kind of aggregate signals for those products. And this is a dynamic list which keeps changing based on the pattern of orders, the pattern of inventory changes, the way inventory planning is anticipating changes upcoming. For example, when the exam or say when the school year is starting, the kind of exam books or the study books are going to be more in demand. So those are all taken into consideration to kind of figure out what's that working set that you need to worry about over the next few days. So this is a high level view of what Promise Engine looks like. So you've got essentially two large clusters. There's a service cluster, which is the one which is the bulkhead, the one which is the web scale system on the right. And I'm not sure if you guys can see the color coding. Can you all see it, the color? If you're in the middle, you probably see it better. But anyway, so this is the service cluster, which is web scale. And we've got an ingestion cluster here, which is listening to events from REST bus, which is coming from all the upstream systems like logistics, fulfillment center, etc. And the ingestion cluster is basically updating a Redis cluster to, which is then being, is the data store for the service cluster. So website makes high throughput requests to the Promise API here, and that's basically just querying the Redis cluster here. So essentially this is an example of the separation of the ingestion plane and the serving plane through a kind of disconnected data store. Plus the service cluster and the ingestion cluster themselves become parts of the entire event ecosystem, and they themselves raise events about promise and availability, so the other systems can build even richer insights and richer behavior on top of that knowledge. So that's the example of this arrow going out to REST bus, notifications going out to the rest of the supply chain ecosystem and other ecosystems in Flipkart. So the next problem that we faced was inaccurate information from underlying systems. When we are kind of asking, say, warehouse, that how much inventory do you have? At that same time, there are actually thousands of orders going through our system and actually kind of reserving orders and kind of changing that view of inventory, right? So we need to worry about things like that. We need to worry about things like a logistics partner saying that it's going to take 3 days to deliver a product and it actually taking 5 days or 4 days, or in some cases even 2 days or 1 day, right? The point is, what he said is not what matches to reality. So how do you kind of calibrate your idea of that confidence measure in that underlying system continuously and actually take some decisions regardless of the promise being made by the underlying system? So even if a logistics partner is saying that it'll take 3 days to deliver, knowing that it's actually 95th percentile is within a day, we can take a call and say, you know what, you'll get it within a day, and deal with the challenges of kind of meeting that at the fulfillment layer. So because we have got that fallback where the fulfillment layer can actually reprioritize and upgrade priorities, even if we are wrong, we can actually do something to kind of recover from that situation. The next item is about this notion of staleness, right? Because we're working on an asynchronous message-based event mechanism, kind of spreading events across the network, across our internal network of services, there's a delay between the time the event is generated and the time it's consumed. Now, there has to be some measure of how stale is this data that I'm seeing. As Promise Engine, I need to know how stale is the data. So we try to characterize that in multiple ways. One is by the size of queues that are built up. One is by actually querying the underlying system in real time synchronously to kind of see if there is a delta between the data that's coming to the event and the data that's being that the system is reporting, and try and keep it within a tolerable limit. When that staleness index kind of deviates significantly, and it happens sometimes because of whatever issues, you have this notion of a redriver. A redriver is a process which basically goes and refreshes your entire cache, right? It goes and basically fetches the latest snapshot of the world and gives it to you, and then you can start afresh. So that's a pretty powerful pattern to use when things go wrong, and things do go wrong. Then it's the aspect of high availability, and we kind of touched upon that in the aspect that the promise engine has to be web scale, the underlying systems don't have to be. So what that gives you is that ability to kind of defer your cost and say, I might not need to have such a large cluster on my backend systems. I might not need to be as highly available as I need to be on the front end. I can actually do much more frequent deploys on my backend systems if required, right? But given all this, Promise Engine still has to be highly available. It has to guaranteed answer a question when the product page asks it, tell me the availability and serviceability of this product, right? So how do you deal with that? Again, a pretty tricky question to deal with. So what we ended up doing was creating this notion of a multi-level fallback client. So Promise Engine actually gives an API, a client API, which is a Java library, which sits on the website end and actually does multi-level fallbacks if things go wrong. So for example, if Promise Engine itself is not performing very well, it's either down or it's responding beyond our expected latencies, it attempts a first level fallback, which will go and attempt to speak to the underlying systems or the caches in the underlying systems, because you don't want to overload them either. But there are some caches in the underlying systems, and tries and gets a promise from there. If those are down, and essentially Promise Engine is not able to, the client is not able to make any progress, it basically falls back to what we call heuristic fallback, right? So heuristic fallback is where it basically makes a educated guess about the state of the world today based on what product is being asked for, knowing that it might be wrong. So it makes a probabilistic guess about it. And these heuristics are being constantly calculated and pushed out to the clients. So this is very powerful. This gives us a lot of flexibility to actually allow system upgrades, maybe downtime, without actually affecting promise too much. There is a delta that you kind of have to deal with, but then you have the other half of the brain, which is the fulfillment orchestrator, which is there to protect your backside a bit, right? It can kind of orchestrate and upgrade stuff and upgrade orders from normal to one-day delivery, etc. Those kind of things automatically. So this is a pretty useful pattern that we've starting to see in many other systems around Flipkart, not only in supply chain, and we're using this a lot. So then there's the aspect of planned and unplanned situations, which is an example is Durga Puja in Calcutta, right? Another is the Ganpati festival in Bombay. Figuring out how does, or maybe even an epidemic in some region, right? A bus strike in Bangalore, which prevents the field executives from coming to office. So there's some which are kind of predictable, you know that it's going to happen at roughly this time. That's the planned events, right? And there are those which are unplanned. So how do you take both those and kind of be able to deal with them effectively? Because the planned ones happen, obviously, you can kind of deal with it, but the unplanned ones are trickier. So what do you do to deal with them? So the way we deal with them is to actually have a very rich capacity-based model of the underlying systems that are making promises. So where you can characterize warehouse capacity in a very accurate way. You can say that the throughput from picking to dispatch or reservation to dispatch is X orders a day today. But tomorrow I can actually tune it down and say it's going to go down to maybe 50% of that. So actually do something about that or fix that problem. So having this notion of capacities at different levels which roll up and aggregate into higher level capacities which can be used by somebody else higher is again a very powerful idea. You can start building systems that start taking decisions on these capacities in very interesting ways. The last is the herd effect. So the herd effect is what happens when, as happened with the Moto G launch recently, we essentially exhausted our inventory in 15 minutes, even though we had thousands of Moto Gs in stock. So essentially the situation is where thousands of people are attempting to buy one product, right? How do you deal with that? It's tricky. So there are two aspects to it. There's one, which is there's this high amount of concurrency you've got to deal with, which affects my inventory level that I show on the website, saying that is this stock available or not. And the second is the fact that because there's so many people ordering, and there is a time lag between the time the order is placed and the fulfillment center or warehouse actually gets a notification of it and can reduce the stock level, and that feedback flows back. There's a time delay. You're basically getting a very high probability that what you're promising is going to be inaccurate. Right? So how do you deal with that? So here we used a notion which is used in many other websites. Let's say you've probably seen it on a ticket booking website or a movie ticket booking website, where moment you enter the checkout process, you're given 5 minutes to complete the process. Right? So this notion of a soft reservation, that when I enter a checkout process, I can actually soft reserve some capacity in my warehouse, but there's an exploding timeline for that. If you don't kind of finish in 5 minutes, that capacity is automatically made available again to others. So, so this idea is pretty useful. And I think what's important from a promise engine point of view is to give that lever of a soft reservation. Typically what happens is the checkout process starts and the website has the option to kind of choose where to apply that lever, where to apply the soft reservation, whether it should be right when checkout starts or should it be when payment is completed, right? And that's again a trade-off between do I under promise or over promise, right? So those are again things which can be learned based on the product, what we're expecting in terms of load, and the place at which the soft reservation actually happens can be tuned at runtime. So once the soft reservation is actually taken, then the checkout process kind of completes, payment completes, and you can have these notion of multiple levels of soft reservation with larger and larger time gaps to kind of recover from. So when checkout and payments are done, you have a 5-minute time window, or till checkout and payments are done, there is a 5-minute window. Moment payment is successful, you get 10 minutes more, because very often you have a process of verifying if it's a COD order, cash on delivery order. We typically call up the person and kind of find out, is that a genuine call, genuine order. So that process takes some time. So this gives you a little more time to kind of deal with that. So there are these multiple levels of soft reservations which can be acquired and released. And ultimately, the order says that, okay, so this order is a true order, we're going to fulfill it, go ahead with it. And the orchestrator says, yes, we're moving forward. At that point, the soft reservation is actually committed and the reservation is created in the warehouse against it, right? So this allows you to kind of deal with setting expectations which are realistic much better than if you didn't have this mechanism. So parting thoughts from our experience doing this. I think many of the patterns that we kind of came across over the last 3 years and kind of implementing the systems, how to deal with the herd effect, a bulkhead service to kind of separate out things, having a fallback, we're seeing that they're widely applicable in systems. And we're starting to see them actually being implemented across not only supply chain, but in other systems also, in website and in retail, etc. What we also notice is this notion of promise and fulfillment, this policy and mechanism, is very core and very powerful. And that once we started going down that path, we're seeing that the underlying systems also naturally fall into actually trying to provide a notion of promise and fulfillment. So now we're seeing our logistics system actually evolving to having its own promise engine and its fulfillment orchestrator. Our warehouse system will soon have that. So essentially, any system which has to do with order processing or has to manage a resource around which has to make offers and do fulfillment will benefit from this. And we're seeing it appear in many of our systems now. What that step allows you to do, or what that enables, is that it gives you very rich control mechanisms. When your underlying system itself has a notion of promise and fulfillment, the guy who's calling it and coordinating that, so you have the Flipkart-wide promise engine coordinating the promises of multiple underlying systems' promises. Now you have a very, very rich interaction. It's not like you're talking to a dumb system, right? What you can do then is actually have a kind of at a control level interactions between these two systems where the downstream system can throttle the upstream system. For example, say I have pre-booked capacity for 1-day delivery in my logistics system with a particular aircraft, right? On a particular day for that leg, delivering from Bombay to Delhi, for example, I'm not seeing that much or that many orders and I've got spare capacity. I can actually tell my upstream promise engine that go ahead and actually give away free next day delivery if you want, or kind of promote this as something, right? So now that's a signal, which is a control signal going from a downstream system upstream. Very powerful stuff, right? You can start actually working together towards actually an ecosystem of platforms which work as in an aligned way towards a certain goal. Yeah, that's all I had. Thank you. Any questions? We'll probably take some questions.
There might be a couple of ways you might be able to decouple your promise from the fulfillment even more. One, you could have like a logical kind of cache at the promise level, which is basically what all inventory you currently have, minus whatever you expect to put it to order, plus what you expect to receive from your supplier network over the next few days, right? And then the individual events don't really need to flow to this promise, because there will actually be a very small fraction of items where the amount that is in the inventory divided by the velocity of how quickly that item is flowing will be actually high enough that your threshold will not be hit. You don't need to do a two-phase commit on every of those transactions, right? So you need to do that only when you are very close to that threshold level.
Sure. So actually, the promise engine does maintain something very similar. I didn't talk about the actual calculations it does to make that happen, but the issue is that there's a very high rate of change in the underlying systems. So yes, you can kind of say that, yes, I'm expecting this much inventory, I've ordered it, but even there, the kind of order, the demand for products can actually vary quite significantly from day to day. So when that happens, you still need to have that ability to kind of go back and listen to the events and react to them. So the buffer is still very much there. You need that buffer and that calculated value, but you need continuous events to come in through to keep updating that, because without that, that's going to go stale pretty soon.
I guess the question was, are there specific sets of items where you could have, say, 100 items, right? But the events that are coming through a day are much less than that, and so you know that you're not going to hit anywhere near the threshold, right? So you could choose not to be totally accurate there, and whenever your redriver process runs, it will readjust all of those.
So redriver is an exception. We don't use that regularly. It's more as when things have gone wrong and you've got stale, it's when you kind of reuse it.
Yeah, you can use it like once a quarter whenever you do the audit.
Possibly, or when things have gone wrong, yeah.
Okay.
You were saying something?
No.
I had a question about the heuristics fallback that you spoke about. Could you clarify it with a few more examples, illustrate it?
Shall I take that?
Yeah.
So let's say that the system learns from the demand, right? What has been happening. So I know there are some locations where like so I talked about the multiple aspects of the promise, right? There's availability, serviceability, different other guaranteed services that we're giving to the customer, right? So I know like from my past patterns, right? That all my logistics partner, all my sellers kind of service a particular set of pin codes. Let's say Bangalore, like almost everybody will be servicing all the products, right? And then that is around the destination or the customer, right? So there's no serviceability issues in these destinations, right? And then there is a set of products which are like very high moving, right? Most of the sellers have it in the stock, right? They will be able to kind of, if I give them an order, even if they don't tell me how much stock they have, but if I get an order, I'm pretty much confident that they will have it in stock, and I can take an order for that, even though I don't have a real-time information around that. So this is how you kind of generally keep on learning around the different aspects about serviceability, availability, SLAs, right? You already kind of know the lead times of the different systems underlying over there. So you kind of basically then learn from these systems and say, okay, maybe I cannot give 100% accurate promise to 100% customers, but maybe I can give a 95% accurate promise to 80% of my customers, right? So rather than, so in a event where some of the systems are downgraded, rather than telling 100% customers, sorry, I don't know what to do, I cannot even promise you can't place an order, at least the 80% of the customers, I can take orders on a very high level of confidence. So that is how we kind of, and we continuously keep on learning about that. So these are just some of the signals, and we actually continuously keep on learning around from these kind of signals, and they will get richer and richer with time. Our systems learn from the past behavior again over there.
So when you say continuously learning, are you talking about automating this process as well?
Yes.
So although you're calling them heuristics, they are more like you have a model at the back end and then you're getting the output. The heuristics are the output of the model. Is that what you're saying?
Yes.
Yes, exactly.
Hi. Can you expand a little bit on the staleness index part? Like, how do you determine that the underlying system has moved away from your current view of the system? Like, I'm assuming that there is no manual intervention here. It's all...
Sure. So one is, actually one very critical indicator for us about staleness across our supply chain is the state of our messaging system, right? So we've got, for example, dashboards and alerts, automatic alerts, which monitor the queue levels across the board, right? And there are alerts whenever, say, for example, the number of pending messages is above a threshold, or the number of unconsumed messages for a particular consumer is above a threshold. It's something to look out for, right? So that's actually what we, by default, that's the page we have open continuously on our in our kind of on-call screens, if you may. The other is to actually do a sampling, is to do something. And we've not yet implemented this, but this is an idea which we want to kind of roll out, which is at every given point, you kind of sample some of the values from the underlying systems and see what the value is. And if the delta is significant enough, you note that and kind of then incorporate that into your measure of confidence of that system and about the delay. So you'll have to separate out the part about accuracy or confidence around the underlying system's reliability and accuracy, and thus the underlying transport mechanism's accuracy. So you need to kind of attribute accordingly.
Okay, let me give one more example. Like, let's say a seller says that I have 10 items for one product in a stock, right? But let's say he told me like this a week back, right? So now it's kind of, this is like a stale data for me. I don't know if I should trust it. So and then we kind of slowly learn about it and say how old data is kind of stale, right? If kind of sellers are telling me every day is kind of fresh, or like sellers telling me every week or every month is fresh, right? So that is how kind of system again kind of keep on recalculating the staleness index and says like, okay, this is such old data. This looks like stale. Let me go and fetch it proactively, even though the seller hasn't told me.
Okay.
Yeah, can I ask one question? Yeah.
Very good.
Yeah.
Okay.
So my question is, there are lots of practical things involved in this, like resellers and customers. So how do you test your system that it's producing the effective result?
So the question is more about, okay, there's a lot of resellers, yes. I think that in terms of correctness, you can still have a much more controlled data set for a test case. Regardless of the size of the data there, you still can actually have a much more controlled data set to kind of test whether the algorithms you're using and given the set of inputs you have, the outputs that you have, that's a very controlled process, so you can test there. But I think what you are also asking is about how often are you asking about, do we measure promise engine itself and how do we improve that, or it's more about the testability of the system itself?
No, the first one.
The first one. So one of the things that we do is to actually record every promise request that came in and which we were able to respond to, whether successfully or not.
So we have a metric like a promise accuracy, right? How accurately we are promising. Are we kind of under-promising, over-promising, right? So those are the kind of metrics that we closely monitor. The promise that we made against which, what was the fulfillment performance around that? And that is how the calibration kind of keeps on happening and we keep on improving around that. Does that answer?
Yeah, thank you.
Right.
Thank you, everybody. If you still have any questions, you can feel free to kind of email it to us. We'll be glad to answer that.
And we're here. So
Thank you.
Thanks, Yogi, and thanks, Vikas, for that interesting talk.